Hello and welcome back. If you want to convert between Cartesian coordinates and polar coordinates, you can use the following four formulas to help you out. X equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tangent theta equals y over x. These formulas can all be generated by taking a point in the plane and drawing a little triangle, right triangle. So drop a little line down, make a right triangle so that the legs of your right triangle are x on the bottom and y on the side. And then r is the radius out to that point. The theta value would be the angle coming from the origin. So if you make that little triangle, all of these formulas fall out of it. If you have cosine theta, that's x over r. So you can multiply the r over and you would get x equals r cosine theta. Same kind of thing for sine theta, that would be y over r, multiply the r over and you get y equals r sine theta. R squared plus equals x squared plus y squared is just a statement of the Pythagorean theorem for that triangle, and tangent theta is y over x in that triangle. Now notice that these help us get between polar coordinates and Cartesian coordinates. If you have something in polar coordinates, an r and a theta, you can get the corresponding x and y values with the first two formulas. If you have an x and a y value, Cartesian coordinates, then you can use the second two formulas to help you get r and theta. Notice that r here is squared, so you actually, when you solve this for r, get a plus or minus the square root of x squared plus y squared. That's because it's possible to have a positive r value or a negative r value with the same point. Also, tangent theta equals y over x has many different possible solutions for any given y and x pair. Remember that you can take the angle theta for any point and add 2 pi to it, and you've got another solution. For example 3, we're looking to take a polar equation and convert it to a Cartesian equation and convert it to a polar equation. So here we're not just dealing with a single point, but rather a whole equation that we're going to convert over. But we still use the same kind of formulas. So in this case, we have a Cartesian equation. It has x's and y's. We can replace those x's and y's with r's and thetas using the first two equations. Now before we do that though, yeah, where's my color? There it is. Okay. Before we do that, notice that, well, one thing is we want to find for our polar equations eventually r equals some function of theta. So if we just replace the x with an r cosine theta and the y with an r sine theta, it's going to be a little bit hard to solve for r. It won't be too bad, but what I'm going to do is instead of directly plugging these in at the beginning, I'm going to take the y minus 3 and square it to give you y squared minus 6y plus 9 equals 9. There the 9's will cancel on each side and when we subtract them off. And we have, and if you look at the, well, here, I'll write it out again. So x squared plus y squared minus 6y equals 0. And if you look at the x squared plus y squared, that is just r squared. And then the y we can convert into r sine theta. So we have r squared minus 6r sine theta equals 0. Now here what we could do is factor out an r. And then set each equation equal to 0. Here we'll get r equals 6 sine theta. And so these are the two possible solutions to this equation. So really the second one, r equals 6 sine theta, will cover both of them, because if you allow theta to be 0, then it covers the r equals 0 case. So I'm going to box that. There's the polar equation that represents this Cartesian equation. So covers both cases means that r equals 0 and r equals 6 sine theta would cover would both be covered by just r equals 6 sine theta. Example 4 says replace r equals 4 over quantity 2 cosine theta minus sine theta with an equivalent Cartesian equation. Now in this case, we want to have, if we want to convert back into x's and y's, it'd be really nice to have r cosine thetas and r sine thetas, because we can replace those with x and y. But on the bottom of this fraction, we just have cosine theta and sine theta. However, if we multiply that denominator over to the left side, we're going to get an r cosine theta and an r sine theta. In fact, when we multiply 2 cosine theta minus sine theta to both sides, we get 2r cosine theta minus r sine theta equals 4. The r cosine theta is x, the r sine theta is y. So we have 2x minus y equals 4. And you might recognize that, that's just the equation for a line. So in this case, with the Cartesian equation, it's much easier to represent this line than the polar equation is. But sometimes polar equations are better. Like if you want to make a circle with radius 1 at the origin, r equals 1 is much easier than x squared plus y squared equals 1. Thank you for watching this video, and see you in the next part.